Hi, hello everyone, this is Mateus from MiningMath, and on today's video I'm going to share a little bit more on surface constraints using MiningMath. Okay, so there's a bunch of things about surface constraints, and I hope this video can be maybe the ultimate guide so far to bring a little bit more insights on the possibilities when dealing with surface constraints. Okay, the first thing to know is the formatting requirements. So basically, surface constraints are defined on MiningMath as a grid of points. Okay, so we have a three-dimensional group of dots and points fluctuating three-dimensionally. Okay. The second point is the fact those points should be aligned with the block centroids. So what we have from these is the fact that the x and y doesn't change. The parameters from x and y doesn't change because they should be equal to the same x and y pair of coordinates from the block centroids. Okay, we'll see just change on the z coordinate. Okay, which is free to change along the z direction, along the vertical direction. In terms of the file format, surface files are defined as a CSV, so it's a text file, and we have a pretty straightforward formatting where we have x, y, and z coordinates in meters. Okay, let's open an example of such a file on MiningMath. So here I have the default data set with a few examples for you, and I can click over here, right click, show in Explorer, and I can go straight to the folder. Okay, so I have a lot of files over here from MineSequence schedule. Okay, so here I have the reports. Actually, the reports are over here. I have the scenario file comprising everything you see on the interface. Okay, I have the mined blocks, which tells me which blocks have been mined, which was the destination for each one, which was the original parameters, etc. And I have the surface files, the surface outputs. I have the topography surface as well. So as you can see over here, this is the surface 1, which represents the parent 1. Okay, and here's it. Pretty straightforward. Okay. If I, for example, if I open the topography file, I can see that values are pretty much the same for x and y in the same positioning. And another important point over here is the fact we should ordinate these coordinates from the smallest to the highest value. So ideally, the configuration, the proper configuration over here is the following one. We need to have a multiple filter using column A, then add a new level, column B, and add a new level, column C. And we need to go from A to Z in all these fields. Okay, so we have the complex, or maybe I don't know if these functionality from Excel has a proper name, but in general lines it's multi-sorting formatting. So I need to sort first the X information, then the Y information, then the Z information. But if I did these separately, it would not work. It could possibly not work, because it could sort the other columns over here. If I start sorting just the X, then possibly the other information might be lost. Okay, So this is the proper way of formatting your surfaces, just in case to have registered for you to become aware. This is important for MiningMath to recognize properly the surfaces. Okay. On SGEMS, let's see. This is the panel from SGEMS where you see MiningMath outputs, and I can, for example, load these surface over here. I can just bring it over here, or I can go to Objects, Load Object, and find manually the output folder and load each folder as well. So here, what I want to see is straightforward. I just bring it to black area of SGEM's panel. Then I select the object type. I select point set, and I click Next. Okay, and I define a name for the surface. Let's say surface 1, okay, as the original name. I have X, Y, and Z. I don't need to change anything, and finish. Okay, so as you can see here, nothing has happened except for this file over here. I just clicked, and I clicked then on the Earth button to refresh it. So visually speaking, these are the output surfaces from MiningMath. Okay, and this is what you can take advantage to use as force mining or restricted mining constraints, or even to conduct, or even to base your open pit mine design. Okay. Okay, so understanding these basic formatting, this is how your surface constraints should look like. Okay, let's move forward then. Okay, so here I would add the third point, or the fourth point actually, which is we need to sort it out. First considering X, then Y and Z. Function of X, Y, and Z from A to Z. Okay, so an ascending order. Okay, so let's move forward.